Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. Let's talk about chemical formulas. We know there are so many atoms and elements on Earth, and we can find any of the elements in this periodic table. So for this table, expect you to know the blocks of metals, nonmetals, transition metals, and metalloids. You can see based on the color here. The right top part are nonmetals. The left part is transition metal from the main group A, 1, 2, 3, and 4, 5, and the lower left part is the metals. So transition metals are in the center, okay? And also metalloids are on the boundary between metals and nonmetals. In the exam, you will not be provided with a periodic table including all these colorful patches. You will just be provided with the periodic table including these boundaries. So make sure if you're provided with any element in the periodic table, you know which group it belongs to, because it's very critical in formulating a chemical formula. Okay. So for elements, we know as a substance, we can have molecular elements and atomic elements. For molecular elements, I previously gave examples of hydrogen, nitrogen, oxygen. They are diatomic molecular elements, but actually all the halogen elements in the 7A group, when they form a substance, they form a diatomic element substance. So fluorine, chlorine, bromine, and iodine. Okay. And for some element, they form tetraatomic substance. You can see the formula here. Also, we have octatomics. Okay, so all of these are called a chemical formula of elements. The subscript here means the number of the preceding atoms in the formula. Okay, the 2 refers to 2 atoms in the formula. The 4 refers to 4 atoms in the formula. And if you look at these molecular elements in the periodic table, it actually are in the nonmetal or metalloid structures. I marked them with different colors boxes, so it's easier for you to remember. Besides these molecular elements, all the rest are atomic elements. So you only need to remember the top part. Also, we have compounds, right? Not just elements, we have compounds. For compounds, we can further divide them into different types of compounds. For example, here, binary ionic compounds. Binary means the compound only made up by 2 elements. Ionic means we have a metal and non-metal in the compound. So when we have these 2 together, there will be electron lose or gain between the 2. A metal lost electron, become a cation. Now it carries a positive charge. A non-metal will gain electron, it becomes an anion, it becomes negative charge. So for cation and anion, whenever an atom, when it carries a charge, it's no longer a charge-neutral atom, it becomes an ion. Okay, for binary ionic compounds, it's made up by a cation, which is a metal, and anion, which is a non-metal. Here is a picture showing the common charge of elements in the periodic table. So you need to remember these common charges. If I give you an oxygen and say, what's the common charge of oxygen? You should know it's -2. Okay, when you make the metals and non-metal together and make a binary ionic compound, remember it's always charge neutral. So you need to trigger some of the subscript to make sure it's charge neutral. In order to remember these common charges more easily, I can share some of the experience with you. So if you see the element in the periodic table, counting from the right to left, the common charge is -1 in the 7/8 row, -2 in the 6A, and -3 in the 5A. Remember this -1, -2, -3 only corresponding to the nonmetals when they become an anion. Okay. And also from the left to the right, if we only look at the main groups, I mean the group with A here, from the very left is +1 charge, the second is +2, and third main group is +3. So again, here we are only looking at the metals. In this case, if you just look at a periodic table, by counting the position of this atom, it can help you to identify the common charge of an atom. The transition metals in the center typically carries multiple charges, with a few exceptions highlighted here. Zinc is always 2+, silver is always 1+, and cadmium is always 2+. So they only have one common charge. Let's take a look at a question. Write down the formula of an ionic compound made of calcium and bromine. So this is a question we need to keep in mind that the compound is charge neutral. How do we come up with a formula? First, we need to write down these two elements or two ions with their common charge. Calcium is here, is 2+. Bromine is here, bromine is here, is -1 charge. So when we put them together, cation first, anion later. Metal first, non-metal later. So when we put them together, we can exchange their charge to their subscript. So what we have now is calcium 1, 2+, bromine 2-. Then we erase all the charges and 1 in the subscript. So finally we have CaBr2. This 2, the subscript here, are the number of preceding atoms in the formula. And because calcium only has 1, we leave out the number 1 in the subscript. This is the chemical formula of calcium bromide. When we have these ionic compounds, sometimes we can have more than 2 atoms. Now, let's talk about polyatomic ions. So these are the ions can be treated as a group. And when we make chemical formulas involving the polyatomic ions, all previous rules apply. For example, write down the formula of a compound made of ammonium and sulfate. So it gives you the charge here. The same thing as before, but now we are treating the whole thing as a group. So first we put together the rough structure, the positive charge first, negative charge second, and then we exchange the charge to their subscription, and then we have this. Because we're treating the ammonium as a group, so we put everything inside of parentheses. Now we can erase all the charge, and in the subscript we can erase 1. So this is the final answer. Because after we erase 1, we can also take out the parentheses of sulfate. So this is the formula of involving polyatomic ions. Now, we've talked about many ionic compounds, but also we could have covalent compounds as another type of compound. Binary covalent compounds only contain non-metal elements. So this is different from previous. And if I give you a formula of a compound and ask you whether it's ionic or covalent, you should be able to tell based on whether the element is non-metal or a non-metal and a metal. Okay, in covalent compound, there's no electron gain or loss. They share electrons between atoms. A lot of things you see are covalent compounds, for example, water, carbon dioxide, the laughing gas. So they are all just made of non-metal elements. They're covalent compounds. Here again, the subscripts indicate how many number of the preceding atoms in the formula, and we leave out the 1 in the subscript. There is a special type of covalent compound called hydrocarbons. Hydrocarbons are compounds that are only made by carbon and hydrogen. So if you write the formula of that, in general, does not know how many carbon are there, how many hydrogens are there, but they only contains hydrogen and carbon. This is actually one of the big group used in gas. It's a fuel, actually. And in the General Chemistry 1 course, we only talk about straight chain hydrocarbons. And they can be put into 3 different categories: alkane, alkene, and alkyne. So they are based on how many bonds, what type of bonds are there. For alkane, it only contains single bonds. And this bond is a chemical bond that connecting nearby 2 atoms in a chemical formula. For alkene, it has double bonds and single bonds. Alkyne has triple bonds. So now we're going to talk about, or I'm going to show you a few structure formulas. It's still a chemical formula, but presented in a different way to show these complicated structures of hydrocarbons. Here shows a structure formula. It shows the carbon backbones and all the nearby hydrogens. Each carbon needs to form 4 bonds with nearby atoms. Each hydrogen forms 1 bond. Also, we can have the line diagram. So it only has 1, 2, 3 ends corresponding to these 3 carbons. And we leave out all the hydrogen and we assume all the carbons are saturated, which means it's all the carbon at maximum can have 4 bonds, right? So all the bonds will be filled by hydrogen. Third, we can have the condensed formula, and we put them into different sections. So on the left is CH3, in the middle is C2, and on the right is CH3. So we don't write all these sticks, we just write this condensed formula. This is an example of alkane. Everything are single bonds. When we talk about the double bond, it's shown here. There's 2 bonds between neighboring carbon, and in this case, this carbon can only bind with 2 hydrogens, and this carbon can only bind with 1 hydrogen. The line diagram is here showing the double bond, and we also have 3 carbons, and the condensed formula shows how many hydrogens exactly I bind with each carbon. For alkynes, here's a structural formula, the line formula, and condensed formula. Please pay attention to line formula that both terminals have a carbon. Also in the center, we have a carbon because you can see where the triple bond ends. Okay, here's still a carbon. So then this is a condensed formula. From the structure and also condensed formula, by counting how many hydrogens and carbons are there, you should be able to identify what type of hydrocarbons it is. All right, I did not indicate in my slides, but there is another thing I'd like to show. 1 second, okay. So for alkanes, it follows the formula of CnH2n plus 2. N is an integer. And once the N is determined, the number of hydrogen is determined. For alkanes, because it has one double bond, it lost the ability to couple with two hydrogens. So the formula is CnH2n. When we have a triple bond, it's CnH2n minus 2. All right, so that's the end of this video. See you next time.